Hello, my name is Marian Novotny, and in this talk, I would like to present Siembol, an open source real-time security information and event management system based on open source technologies. Let me introduce myself. Currently, I'm working as a software engineer at G Research, where I'm developing applications for security monitoring and intrusion detection. In past, I worked as a specialized software engineer at ESET, where I was responsible for designing and implementing network intrusion detection systems that were integrated into various ESET products. I did some research in security at the university, where I focused on analyzing and designing security protocols. When I joined G Research, the team used Splunk for security monitoring that worked quite well. Because of the expensive license, the team decided to build a custom security data platform based on open source technologies. They chose Apache Metron as a core component of the platform, and we started implementing missing features and plugins for Metron. We recognized the limits and issues of Metron mainly in configuration management, and we started implementing a custom data processing framework to replace Metron. The transition was not easy. We used to live a very long time together with Metron and replace the component by component. Metron was moved to Apache Attic at the same time when we decommissioned it internally. This brings the opportunity for Siembol to become an open source alternative for SIEM tools. After writing documentation and maturing the code base, we have decided to open source Siembol and present it at security conferences. We followed Metron data pipelines architecture, but we added components for alert escalation and incident response handling that were missing in the Metron architecture. The log after ingestion is normalized by Parsing Application. It's normalized to flat JSON with common fields such as timestamp, host, or URL. The event can be enriched by an enrichment component from tables based on rules. For example, we can enrich an IP address by a DNS name or an asset by its classification. The events are evaluated by alerting component, and alerts can be correlated with others in a correlation alerting component. The escalated alerts are then handled by response component that integrates Siembol with tools used for incident response. Let me know that data ingestion, indexing, and internal system are not part of Siembol, but they are implemented in other components of security data platform. I consider Siembol UI as the biggest improvement over Apache Metron. If we would like to scale to thousands of configurations, we need to have configuration management with a clean separation of duties. It should support validation and testing configuration before they are deployed into production. This is a screenshot of the Siembol UI landing page. The list of services is based on user permissions and authorization. One Siembol UI deployment allows multiple service instances of the same type to be used by different teams and users. During editing configuration, we distinguish between store and deployment. In the store, the user can edit and save configuration without deploying it. Siembol UI is using Git repositories for storing configurations, and all changes are committed by UI using a user as a committer. This way, we have a clean, auditable history of changes. At some point, user can promote the change and deploy the configuration by creating a pull request in the Git repository. After reviewing and merging, the configuration can be released to Siembol components. The configurations are stored in JSON form and edited by web forms. This allows us to edit a complex configuration and provide validation in order to avoid errors and mistakes in production. Moreover, Siembol UI supports testing configurations and creating test cases that are stored in Git repository. A test case store input for testing configuration, along with simple language with assertions that should pass during evaluation. This can help to avoid errors if the configuration is edited in the future, possible by someone else than former author. Siembol UI using Git for storing configurations. All configurations are edited by forms and stored as JSON files. Siembol UI supports OAuth, OEDC, authentication, and authorization. Authorization for a service is based on a user group membership. Siembol UI supports high integrity use cases. It creates pull requests during deploying configuration. The pull request can be reviewed before merging and releasing to components. When we implemented the parser in Metron, we need to write Java code, compile, test, and release it as plugin. This process takes time and can be error-prone. We have decided to build a custom parsing framework to speed up onboarding a new data source. A parser is created and edited in Siembol UI, similar to other configurations. First, a log is parsed by a basic parser, such as syslog. Then a chain of extractors is executed to extract important fields, such as timestamp. And finally, the fields are cleaned by transformations, where we can normalize values or fields, rename fields or filter fields, or the whole message if it's not needed in further processing. This is an example of AWS CloudTrail parser. It's a generic parser, and JSON extractor is applied on original string. The timestamp is extracted from event time field, and the fields started with request parameters resource are deleted during transformations. A parser can be integrated in a single application or can be combined with other parsers in a router parsing application to speed up onboarding a new data source. A parser is selected based on a routing field. This allows us to maintain in big parsing applications that collects logs from multiple data sources. Metron uses HBase for storing enrichment tables. We had issues in production environment with stability and performance of HBase tables during enriching events. We have decided to use only in-memory tables that are sufficient for our use case. Enrichments are defined in rules which are edited in Siembol UI, similar to other configurations. This is an example of enriching an IP address by a domain name. The rule is applied after matching the field IP destination address, and the table with name DNS is joined with the event using the IP address as a key. If the table contains the IP address, then the event is enriched by the field DNS name. Metron has no dedicated component for alert escalation. We have decided to build a custom framework for real-time stream evaluation of detection rules without the need to index or store events. Siembol alerts are edited in Siembol UI, similar to other configurations, using web forms. This is an example of AWS failed authentication, and in this rule, we are matching event name field with console login and error message field with failed authentication. We would like to add tag correlation key with value stored from the field user identity principal ID. A simple alert can be escalated directly to the Siembol Response component, or it can be used for correlation with other alerts in the correlation alerting engine. This is an example of AWS brute force login rule. And in these rules, we are correlating AWS failed authentication alerts in 1 minute time windows, and the threshold is set to 10. Siembol UI supports importing a Sigma rule into a Siembol alerting rule. You can import rules using Siembol UI, and you can define imported attributes such as field mapping and rule metadata mapping. You can copy-paste Sigma rule, and then after clicking import, you have imported Sigma rule into Siembol alerting. Siembol Response is a component for handling a response to an alert. In a rule defined in Siembol UI, SOC team can automate their incident response by enriching alerts by doing additional ELK searches, LDAP, or virus total searches. Siembol Response allows filter alerts in this stage and avoid handling false positives. Escalated incidents, cases, or issues can be created with internal systems such as the Hive or Jira. Siembol Response has a plugin architecture that allows the implementation of custom integration with internal system if needed. The plugins are also integrated into Siembol UI, so you can edit rule with your custom evaluators directly in Siembol UI. We believe that Siembol architecture allows us to scale with number of events and configurations. This is a whole picture of Siembol components. Siembol UI adapts microservice architecture with single-page applications, which is developed in Angular, and REST API developed in Spring Boot. Siembol UI using identity provider for authentication and authorization, and it's using GitHub for storing configuration and managing pull requests. Siembol REST adapts modular architecture. To validate and test configuration, it includes the same modules which are used in Storm applications. One exception is Siembol Response with a microservice architecture. And Siembol REST API is using HTTP calls for testing and validation configuration because Response loads plugins, and we don't want to load the same plugins in multiple components. Siembol adapts desired state pattern to release Storm topologies. This desired state is computed by Siembol REST and synchronized using Zookeeper. Storm Topology Manager kills and starts topologies based on the desired state. Siembol CI/CD pipelines build 7 Docker images and release Java packages to central Maven. We are publishing Kubernetes Helm charts to easily deploy Siembol on Kubernetes cluster. Siembol can be used as security information and event management system using open source big data technologies. Siembol architecture allows us to process 150,000 events per second at GR. We are onboarding 83 data sources and evaluate around 300 detection rules. This is executed in 27 Storm applications and 5 Kubernetes pods. We believe that Siembol architecture allows us to scale up the number of events and number of configurations. Siembol can be used as a detection tool for real-time detection of leaks and attacks on infrastructure. We are using Siembol for detecting leaks on HDFS, but it can be used for detecting attacks and links on other platforms too. It can replace expensive tools and can be used without need to index events. In the demo, we would like to show you how to try Siembol in 10 minutes on Minikube using Quick Start Guide from our Siembol repository. The demo will follow Quick Start Guide from GitHub repository. So you need to install Minikube and dependencies using provided scripts. Currently are installed dependencies such as Kafka, Storm, and Zookeeper. And we have prepared Siembol config repository with simple configurations. And you need to fork this repository in order to follow this quick start guide. So you need to fork repo and generate GitHub access token. Going to developer settings and generating token. You need to select repository scope. And then follow script demo install, which generates config mask and secrets for Siembol REST API, and also generates Zookeeper nodes. So you need to provide information about your fork repo. It generated access token. Now the scripts is creating zookeeper nodes. At this stage, we are ready to install Siembol Helm chart by copying command. And so now Siembol UI and REST and Stock Topology Manager are released. And since we have in Siembol config a few configurations with Storm applications, these applications are now released by Storm Topology Manager. These topologies are released by launching Kubernetes jobs. So now the process is started. And we can have a look in Storm UI and look for Storm applications that are now launched. So 2 applications have been released. And now all 4 applications are released. So now we can look at Siembol UI. And we can show how can we edit parser config. This is event log parser based on syslog with key value extractors. We are showing you how can you evaluate test case, and we will use this log from test case for evaluation Mimikatz demo at the end of the. Now we can edit configuration. As you can see, currently is submitted version 5, and after submitting in store, the version is changed version 6 with one change in the description, and we can promote this change into deployment. But before we can see the difference, and we can upgrade to version 6. And by deploying, we will create pull request in release repository. We can check and review and merge the pull request. As you can see, the changes in the description. Now we can look at admin configuration in alerting. In admin configuration is defined properties of Storm application, Kafka, Zookeeper, and parallelism. And we can have a look on Mimikatz rule and try test case. Now we would like to show you sending messages on parsing topic and parse event log message with Mimikatz detection, and we will see the communication of Siembol topics. For this purpose, we are installing Kafka UI and try to connect the port and send message to event logs parsing topic. So we are connecting to pod in order to produce message on topics which is read by event log parser. We can copy the log for parsing from test case. And topic is win.eventlogs. And we can copy the log from test case from Siembol UI. So we'll go to parser config, and in one test case we have log that should match the Mimikatz detection. So we will send this log into topic for event log parsing, and event log parser should publish parsed message into symbol.indexing topic. So we will check whether the message was parsed. And symbol.indexing topic is evaluated by alerting engine with Mimikatz rule. Okay, so now it's the message was published to symbol.indexing, and now we can check symbol.alerts whether this event was escalated as alert by Mimikatz rule. As you can see, the rule of win Mimikatz has matched, and the alert was published. Siembol is not a one-man project, and I would like to thank all Siembol contributors. If you are interested in the project, please visit our webpage, siembol.io, or you can have a look at our GitHub repository, gresearch/Siembol. Thanks for attending the talk.